This is the fifth video in our Algebra Foundation series, and this is an opportunity just for me to introduce you to, if you don't remember, or remind you of, if you remember from last year, the concept of square roots. Now, square roots is an operation that you can do on a number to figure out what number squared produced that number. So a way of looking at this is some number x times itself, or squared if you will, is equal to some other number. Square roots is taking this backwards. So we could say 2 times 2 is equal to 4. And therefore you would say the square root of 4 is 2. And the other way of writing that is with this symbol, which is the square root symbol. So this says the square root of 4 is 2. Now that's great for those perfect square numbers like 4, 9, 16, 25, and so on and so forth. Those are all perfect squares. We call them perfect squares because when we take the square root, as in the case of 25, we get an integer, 5. Every number has a square root, but not every number has an integer as its square root. Some square roots are irrational, like the square root of 2. The square root of 2 is a non-repeating, non-terminating decimal, like pi, goes on forever, so it is a rational number. It does exist. We can estimate it, but it is irrational. So the number which multiplied by itself and equals 2 is an irrational number, like pi. It's not pi, but it's like pi. So we have our perfect squares like 4, 9, 16, 25, but it's important to note that every number can have a square root. In fact, not just numbers, but expressions and terms can have square roots too. The square root of 4x squared, for instance. This is a perfect square term, and the square root of this is 2x, which is to say 2x times 2x would produce 4x squared. So those are square roots.